A blue whale begins its journey beneath a sky with no visible landmarks. There are no roads across the ocean, no signs pointing toward feeding grounds, and no fixed line that every whale must follow for generations. People described whale migration as a simple seasonal journey feed in cold, productive waters, then swim toward warmer regions to breed and give birth. But the movements of blue whales are far more flexible than that image suggests. They may pause, turn, explore, feed, remain behind, or follow routes that differ from those used by other members of the same population. For the largest animal in history, migration is not a straight road between two destinations. It is a series of decisions made across thousands of kilometers. The journey begins with an energy problem. A blue whale carries a body that may weigh more than 100 tons. Moving that body across an ocean requires a vast amount of energy, even when the whale travels efficiently. At the same time, migration may lead through regions where food is scattered or unpredictable. The whale cannot assume that every kilometer ahead will contain enough krill to support it. It must decide when to keep moving and when an opportunity is valuable enough to interrupt the journey. The traditional picture suggests that a whale feeds intensely before migration, stores energy as body fat, and then travels toward warmer water while eating little or nothing. This pattern may describe part of the lives of some baleen whales. But blue whales do not always obey it perfectly. Tracking and biologging research has shown that pygmy blue whales off Western Australia can perform feeding dives while moving along their migration route. They are not simply traveling past the coast. They are searching beneath the surface, locating prey, and taking advantage of food encountered along the way. This behavior changes the meaning of migration. A route is not only a corridor connecting one seasonal habitat to another, it can also contain temporary feeding grounds, resting zones, and places where a whale changes its plan. A blue whale may travel steadily for hours, then slow down near an ocean front, canyon, or region where currents concentrate prey. Its movements may become curved and localized rather than direct. It may dive repeatedly, remain within the same area, and then continue north or south once the feeding opportunity has declined. From the surface, such a change may be almost impossible to recognize. The whale breathes, disappears, and later surfaces somewhere else. But satellite tags reveal the path left behind. A direct migration appears as a long sequence of movement in one general direction. Foraging behavior often produces a different pattern: slower travel, repeated turns, and more time spent within a limited region. Biologging tags can reveal something even more detailed. They record depth, speed, body orientation, and rapid movements associated with feeding lunges. Together, these technologies show that some migrating blue whales do not merely stop over promising habitat. They descend and actively feed. Why interrupt a journey that may already take weeks or months? The answer lies in the value of krill. A dense swarm can contain enough energy to repay the cost of diving, accelerating, and opening an enormous mouth. If the prey is concentrated in the correct place, several successful lunges may provide fuel for the next stage of migration. Ignoring such an opportunity could force the whale to rely entirely on stored fat, while feeding allows it to protect or rebuild those reserves. Yet, not every patch is worth stopping for. A blue whale cannot efficiently chase individual krill. It requires dense swarms. The whale must evaluate whether the prey beneath it is concentrated enough to justify slowing its journey. If the food is poor, continuing toward a more reliable region may be the better choice. Migration, therefore, becomes a moving calculation between distance, time, oxygen, prey density, and stored energy. The ocean itself helps create these decisions. Currents meet and form fronts. Deep water rises toward the surface in upwelling zones, carrying nutrients into sunlight. Submarine canyons and changes in the seafloor can concentrate prey. Winds and tides reshape productive areas over days or even hours. A place that appears empty on one journey may contain a dense feeding opportunity during the next. The whale must combine memory with information gathered in the present. Memory is likely essential. Blue whales can return seasonally to productive regions separated by enormous distances. Some individuals show loyalty to particular feeding grounds and routes. The whale may remember where food was found in previous years, but it cannot depend on memory alone. Ocean conditions change. Krill may arrive earlier, later, farther north, or at a different depth. A successful migrant must follow familiar patterns while remaining flexible enough to abandon them when conditions are different. This means that two whales beginning from the same region may not make identical choices. One may continue traveling through an area while another stops to feed. One may remain near a productive feature for days. Another may move toward a destination hundreds of kilometers away. Their decisions can be influenced by body condition, age, sex, reproductive state, experience, and the quality of the food they encounter. A pregnant female, a nursing mother, a young whale, and an adult male do not face the same energetic demands. A female supporting a calf may need to protect her own reserves while producing milk and guiding a slower companion. A young whale may have less experience and lower energy storage than a large adult. A male may time movement partly around access to potential mates. Research examining chemical records preserved in baleen has suggested that age and sex can be associated with different migration patterns, even within the same species. The ocean is experienced through different biological needs. Some blue whales may also travel only part of the expected route. Migration does not always require every animal to move between the same extreme northern and southern points. Certain individuals may remain in productive middle latitude regions. Delay departure, arrive early, or continue feeding during periods once considered part of the non-feeding season. Evidence from chemical analysis and acoustic monitoring suggests that some blue whales use winter habitats more actively than the simple migration model once assumed. This does not mean migration has no structure. Many blue whale populations still show broad seasonal movements associated with feeding and reproduction. Productive waters at higher latitudes can support intense feeding, while lower latitude regions may be important during breeding and calving periods. But within that broad rhythm exists enormous variation. The route is more like a flexible network than a single underwater highway. Pygmy blue whales in the eastern Indian Ocean provide a powerful example. Many feed in productive waters off southern or western Australia and move toward lower latitude regions of Indonesia. For years, scientists knew major parts of this route, but had limited information about what the whales did between well-known areas. Satellite tags eventually showed that the animals could spend time in regions along the coast rather than passing through at a constant speed. More recent biologging work documented feeding behavior during the migration itself. A whale may therefore leave one recognized feeding ground without truly ending its feeding season. It carries the ability to search for opportunities as it travels. When it encounters the correct combination of prey and ocean conditions, the long-distance traveler becomes a hunter again. Its body tilts downward. The slow, directional journey is replaced by repeated dives at depth. It accelerates into a krill swarm, filters the prey, returns for air, and dives again. Hours later, the whale resumes migration with more energy than it had before the stop. This flexibility may be one reason blue whales can survive in an ocean where resources appear in patches. Krill are not spread evenly across thousands of kilometers. They form temporary concentrations shaped by temperature, currents, food, and predators. A rigid migrant that refused to feed outside one traditional location could miss valuable opportunities. A flexible whale can use a chain of habitats rather than depending entirely on one destination. But flexibility has limits. A blue whale cannot feed successfully wherever it chooses. The prey must exist in sufficient density. An ocean front may shift. An upwelling system may weaken. A marine heatwave may reduce productivity or move krill away from a traditional route. Climate change can alter the timing and location of feeding opportunities faster than long-lived animals can adjust their inherited and learned movement patterns. A route used successfully for decades may become less profitable. The whale may arrive at a remembered feeding area and find little food. It can search elsewhere. But searching also consumes energy. Every detour adds distance. Every unproductive dive spends oxygen and time. The same behavioral flexibility that allows adaptation cannot create krill where an ecosystem no longer supports them. Human activity adds another risk. Some migration corridors and feeding stopovers overlap with major shipping routes. A whale that slows down to feed may spend more time near the surface, cross the paths of vessels repeatedly, or become less aware of approaching danger while focused on prey. Ship strikes can occur in the same productive coastal waters that attract both whales and human traffic. Fishing gear creates entanglement hazards, while underwater noise can interfere with the acoustic environment blue whales use to communicate and possibly orient themselves. Protecting only the best-known feeding and breeding grounds may therefore be insufficient. The spaces between them matter. A location that appears to be merely part of a travel corridor may actually function as a refueling station. An ocean canyon visited for only a few days could provide energy essential to completing the journey. A region used by some whales but ignored by others may still be crucial for mothers, young animals, or individuals migrating during unusual environmental conditions. This makes tracking individual whales especially important. Population averages can hide the decisions that determine survival. If most whales travel directly, but a smaller group repeatedly feeds along the route, both strategies deserve attention. If females, males, or different age groups use separate areas, protecting only the most crowded location can leave important animals exposed. The migration of a species is built from many individual journeys, and no two may be completely identical. Imagine a pygmy blue whale moving north along the coast of Western Australia. It has already traveled hundreds of kilometers. The broad direction of the journey is familiar, perhaps shaped by experience accumulated over many years. But the whale is not following an invisible rail. Ahead, currents pass over complex seafloor features and gather prey into deep layers. The whale senses a change in the environment and slows. Its next movements are no longer direct. It turns, dives, and begins searching beneath the surface. A dense patch of krill appears below. The whale accelerates, opens its mouth, and engulfs water filled with prey. It returns to the surface, breathes several times, and descends again. For part of the day, migration has paused. Feeding has become more important than distance. Eventually, the prey disperses, or the whale gains enough energy to continue. It turns north again. Behind it remains a place that human maps may not label as a major blue whale habitat. Yet the stop has changed the energetic balance of the journey. The whale now carries fuel gathered on the road. Farther ahead, another whale may pass the same location without stopping. Perhaps the prey is no longer dense. Perhaps that animal has greater energy reserves or follows a different timetable. Both whales belong to the same species, but each journey responds to a unique combination of memory, opportunity, and need. This is the secret of blue whale migration. The journey is seasonal, but it is not mechanical. The whales do not leave one point, follow a perfectly fixed line, and arrive at another on a predetermined date. They explore, evaluate, remember, and adjust. Some feed while moving, some delay departure. Some use different habitats according to age or sex. Some may remain where others continue onward. The largest animal in history survives not by controlling the ocean, but by responding to it. A current changes, and the route bends. Krill gather, and the journey pauses. Food disappears, and the whale moves again. Migration is not simply movement through space. It is a conversation between the body of the whale and an ocean that never remains the same. From above, the path may look uncertain, filled with turns, loops, and interruptions. But each deviation can carry meaning. A curve may mark a search. A cluster of dives may mark a meal. A long pause may reveal a hidden habitat. What appears to be wandering can be a sophisticated strategy for crossing a world where the next source of energy is never guaranteed. The blue whale has no map we can see. Its route exists within memory, instinct, sensory information, and decisions made moment by moment. It travels toward distant seasonal destinations, yet remains ready to change course when the ocean offers something valuable. The road is not fixed because the ocean is not fixed. And for a traveler larger than any animal that has ever lived, survival may depend on knowing when to continue forward and when to stop.